Hello friends, welcome back to your UPSC. Today we will be starting with climatology, and in climatology our first topic will be ocean bottom relief features. So let's get started. So ocean bottom relief features. See, we have our lithosphere. In lithosphere we have studied various landforms. Now these landforms are like mountain, plateaus, plains, etc. And we have about 3/4 of area that is covered with water. Now, only 1/4 of area is covered with land, and this area is having so many relief features. So there must be some relief features in the ocean bottom also. Now, first we will look into some basic informations. We all know that 3/4 of our globe is covered with hydrosphere, and hydrosphere it covers about 70% of total surface area of Earth. And if we divide on the basis of hydrospheric division, we have first oceans that cover largest area of hydrosphere, then we have inland seas, then we have small enclosed seas, lastly we have bays, etc. And in oceans, we have Pacific Ocean that occupies the largest area, then we have Atlantic Ocean, and lastly we have Indian Ocean. And these three oceans are significant oceans. Okay, so we were talking about ocean bottom relief features. See, till the time of Second World War, people used to think that the ocean bottom is flat. Okay, it does not have any relief features or something like that. But during Second World War, there was use of submarines. Okay, so the Navy they used radar technology to locate these submarines. Now, for locating these submarines, they used radar technology. In radar technology, they actually send radar, and this radar is reflected back as it hits the submarine or any hard object. So, with this, they can locate where exactly the submarine is. So, this technology was used at that time. Now, Dr. Harry Hess, because he was a geomorphologist by profession, and he also joined army during the time of Second World War. So what he did during his free time, he sent radar to look into the depth of ocean. Okay, but to his surprise, what he found that somewhere the depth was quite deep, while somewhere it was quite shallow. Okay, so with this he concluded that the ocean bottom is not flat as we used to think. Okay, with this he gave the theory of seafloor spreading that we have already done. Now this was the how this theory evolved. Okay, now we will look into submerged oceanic water relief features. What exact relief features do we have in the oceans? So the first and foremost relief feature will be continental shelf. Continental shelf, see, we have continental margin area that is submerged, continental marginal area that is submerged under the oceanic water with an average depth of 100 fathom and gently sloping towards the sea or the ocean. So this is our continental margin, and the part of continental margin that is submerged in the ocean having a depth of 100 fathom. Okay, 100 fathom is actually equal to 1 fathom is equals to 6 feet, so 100 fathom will be equal to 600 feet. So the average depth will be 600 feet, and the angle or the slope will be 1 to 3 degree. So this is very gentle slope, and this slope will be towards the ocean or the sea. So this is known as continental shelf. Now we have various theories which gave the or which tells us about the origin of continental shelves. Now the first theory is marine erosion and fluvial deposit. So in marine erosion and fluvial deposit, we can see that continental shelves are basically extended form of continental platform. Okay, this is our continental platform, and this continental platform is extended towards the sea, and this is only known as continental shelf. Excuse me. So now the marine waves and currents which erode the continental margin. So continental margins are eroded by marine waves. Okay, and these waves, they erode these continental margin, and the deposits which they receive are collected or sedimented, and they are sedimented in this area, okay, near the continental shelf. So thus we can say that continental shelves are formed from marine erosion and fluvial deposit. And fluvial deposit, why fluvial deposit? Because these sediments which are deposited, they are received by the river and they are brought to the sea or ocean by the river. Okay, so hence this is known as fluvial deposit. Next theory we have river deposition. Now, continental shelves are formed through prolonged deposition of detritus or undersea water, brought by a river alone. Some of the scientists says that these continental shelves, they are formed from the sediments that are brought by rivers alone. So marine erosion is not involved. Okay, such type of continental shelves are formed only in those areas where sea conditions are calm, and so this is our continental margin. So the river is bringing sediments, and these type of continental shelves, they are formed when the sea is calm, so that these deposits, they are not eroded away. Okay, so these deposits, when they are not eroded away, they get or they collect in this area and they form continental shelf. So this is how continental shelves are formed, and these type of continental shelves are constructional and they are more extensive. Okay, so these continental shelves, they extend till a long area. Next we have subsidence of continental margin due to rising thermal current, convective current. Now what happens? The rising thermal convective current that is formed beneath the ocean basin and continent, they converge along the continental and ocean boundaries. So this is the continental boundary and this is oceanic boundary. Okay, so they converge, and because of this, what will happen? This oceanic plate being heavy, it subsides, but along with it, some part of continent or continental margin, we can say, it also subsides, and this subsided part forms continental shelf. Okay, next we have tectonically formed continental shelf. Tectonically formed continental shelves, they are actually formed when the parallel fault are created in the continental margin. Okay, so during this time, what happened? The marginal land area, it subsides and submerges under the seawater. So because the faults are formed, the one part will subside. So these are the fault. One part will subside and it will be submerged inside the water. Okay, and this submerged part become the continental shelf. Then we have glacial control theory. Glacial control theory, it states that the continental shelves are formed through marine erosion of the continental margin when the sea level falls. Either and this occurred either during the ice age or during the subsidence of oceanic floor. So during the ice age the sea level falls, or during the subsidence of oceanic floor the sea level falls. Okay, so this time what will happen, the exposed land area where the, so if the sea level will fall, or this was initial water level. Okay, so this was initial water level, but this water level now comes down till this. Okay, till here. Now this fall in water level, what will happen, the large area will be exposed and this area will be glacially eroded, and this area will be glacially eroded, and here extensive platforms will be formed. Now when the ice age was over, the ice melted and the sea level, it raised again. Now this area which was initially, or which was previously exposed, it went back in the water, and this area, submerged area, formed continental shelves. Okay, and this theory is known as glacial control theory. So in this we have ice age, or submergence of oceanic floor, or subsidence of oceanic floor, which exposed a bit of area, okay, bit of its oceanic area, land area, and this land area, due to glacial erosion, it forms extensive landforms, and these extensive landforms are again covered with water when the ice age is over, and these extensive area are now known as continental shelves. Next we have coastal land erosion. So coastal land erosion are effectively eroded through ab- abrasive work of the strong sea waves. Okay, so the strong sea waves, they actually will form several sea cliffs. Okay, these sea cliffs will gradually and continuously recede towards the land, and due to the basal erosion and consequent fall in their hanging crest, so this is cliff is formed, okay, by the wave erosion, and this area when it enlarges, or we have this hanging part, so this will break down, and this broken part, it will form a platform here, and this platform, when it will be covered, submerged under the seawater, it will form continental shelf. Okay, now lastly we have tilting of land towards the sea. In this what will happen, the continental margin will towards the submerge inside the water because of tilting of lands towards the sea, and because the land is tilting towards the sea, continental shelf will be formed, and because of this process what will happen, the existing continental shelf will be extended. Okay, so this was about continental shelves. The second feature is continental slopes. Continental slopes are exactly, this is our continental margin, this is our continental slope, sorry, continental shelves, and this area, or the zone of deep sea plain extending from continental shelf to deep sea plain, having a slope of 5 or more than 60 at different places. So this will be having steeper slope as compared to continental shelf. Okay, so this area between continental shelf and deep sea plain is known as continental slope. Okay, and the depth of the water over continental slope varies from 200 meters to 2000 meters. Okay, so these continental shelves, they occupy only about 8.5% of the total area of ocean basin. Okay, and their theory of origin is actually given by or related to various authorities. Okay, and these are, first is erosional process, second is tectonic process, and lastly we have aggradational process. So in erosional theory, see, we have most significant relief features in the continental shelf, and that is submarine canyons and trenches. So because we have submarine canyons and trenches that are formed in continental shelf, so based on their presence, some people say, or some geologists, they say that geographers, they say that the continental slope, it is formed by erosional process. Okay, and according to this theory, uh, the continental slopes, they are formed due to erosion by marine processes, and the main marine process here is sea waves. Then we have tectonic process. Now according to tectonic theory, faulting is held responsible for the origin of continental slopes. So in this one we have wave action, that is responsible for formation of continental slopes. Then in tectonic we have faulting, that is held responsible for the formation of continental slopes. Lastly, we have a gradational process, and according to this process, some exponents, they believe that the continental slopes are formed due to bending and warping of continental shelves, followed by sedimentation. Okay, so here they are formed due to bending, warping, followed by sedimentation. Okay, then we have deep sea plain. Deep sea plains are actually flat rolling submarine plains, and they are most extensive relief zones in the world. They cover about 75.9% of total area of ocean basin. Okay, so they are most extensive, and here we can find many relief features. So we will have like, this is our continental margin. Here we have continental slope shelves. Then we have continental slope. Here we are having deep trenches, and then we will have oceanic floor. Okay, and the depth will here will be about 4 kilometers from the sea floor level. Okay, so these trenches, they are formed in convergent or active continental margin, or if they are not present, we will normally have continental shelves. After the continental margin, then we will have continental slope. then continental rays, and then abyssal plain. Okay, so this is how we will have ocean bottom or configuration of oceanic floor. Now this oceanic floor will be having various features like rift valley, guyots. Guyot is also known as sea tableland. Then we will have sea mounts and various other things. So these deep sea plains, they cover about 75.9% of total area of oceanic basin, and there these sea plains are characterized by pelagic deposits of plants, marine animals, and siliceous remains, but there is absence of erosional debris of trigenous origin. Okay, so this is how they are formed, and sometimes there are few reports that we also found volcanic deposits in deep sea plains. So these three, that is plant remains, marine animal remain, and siliceous remain, they are the main ingredients of deep sea plains, which constitutes deep sea plain. And then we also have volcanic deposits. Okay, then we will have ocean deeps. Ocean deeps, they are representing depressions and trenches on the ocean floor, and they are the deepest zone of ocean basins. Okay, now these ocean deeps, they are generally located parallel to the coast, facing mountain and along the islands. So they are either along the islands or they are parallel to the coast, facing mountains. Now we have ocean deeps in two way. They are in two forms. First is deeps, and another one is trenches. So deeps are actually very deep. They are very deep, but less extensive depressions. Okay. Then we have trenches, which are long, narrow, and linear depressions. Okay. And they both of them are characterized by very deep slope, and sometimes they actually their rise is almost vertical, so they are like this, almost vertical. So some of them are Murray Deep, uh, then we have Japan and Sudan trenches, then we have Mariana Trench. So there are many ocean deeps. Now we will have submarine canyons. Submarine canyons, they are long, narrow, and very deep valleys or trenches located on the continental shelf and slopes. Okay, with the vertical wall resembling the continental canyons. So, like continental canyons, we have submarine canyons which are located on continental shelves or continental slopes, and they also have vertical walls. Now, on the basis of morphogenetic process, they are classified into two. First is glacially eroded canyons, and another one is non-glacial canyons. So, the non-glacial submarines canyons, they are more in number as compared to glacial canyons, and they are actually these non-glacial canyons, they are widespread all over the ocean, and hence they are studied in much more detail. Now we can see various canyons in different ocean. So in Atlantic Ocean we can see Hudson Canyon, then we can have Mississippi Trough, then Congo Canyon, etc. etc. In Pacific, we have Columbia Canyon, Montrep Canyon, then we have Panama Canyon, and various other canyons. In Indian Ocean, canyons are found along eastern coast of India and in front of Indus River, along the northeastern coast of Sri Lanka, and along eastern coast of Africa. So this was basic distribution of submarine canyons in all the oceans. Now we will look into origin of canyons. There are various theories related to the origin of canyon, and there are divergent opinion about the mode of origin of submarine canyons. But majority of exponent, they consider them as the recent geological phenomenon. Okay, so they actually consider them from mainly from quaternary period. Okay, because we can see that many canyons, they are still in the process of formation. So we have like three theories, sorry, four theories which explain the origin of submarine canyons. So the first one is diastrophic theory. Diastrophic theory, it states that the tensional forces caused by earth movement due to endogenetic process results in the formation of fault and grabens on the continental shelves and slopes, and this fault and trough become submarine canyons. Okay, so these faults, they become submarine canyon. The fault that we see on the continental shelves or slopes are known as submarine canyons. And similarly, we can also say that warping or steep folding can also give birth to synclinal basin or synclinal trough, which also represent submarine canyons. Okay, so this was the first theory, but this triastrophic theory, it was criticized mainly on three counts. First one is the majority of submarine canyons, they are found transverse in the coast. Okay, and so they are found transverse, but the faulting, it generally occurs parallel to the coast. So canyons are like this, but faulting, it generally occurs like parallel to the coast. So how the canyons can be formed by this tectonic movement, or sorry, from faulting or folding. Next we have many of submarine canyons, they have dendritic pattern of their tributaries which cannot be explained through faulting. Okay, so they are having dendritic pattern, so this can't be explained through faulting process. Lastly, we have not all the continental shelves and slopes show evidence of faulting, but we have some of the continental shelves or slopes which do not have any, or which do not show any evidence of faulting, but they are having submarine canyons in them. So how in them submarine canyons are formed? So this diastrophic theory, it can explain the formation of continental slopes, or sorry, the canyons along the Pacific coast and Mediterranean Sea, but along the Atlantic coast, this such movement can't be explained. Okay, so this theory failed to explain the formation of submarine canyons in Atlantic coast. Now, this leads us to another theory, that is subaerial erosional theory. Now, this theory was actually originated because several exponents, on the basis of its resemblance of submarine canyon with the continental canyon in shape and deposition, So they related the formation of the former to the entrance of river valley in the running water and subsequent drowning of these valleys due to subsidence of summer and submergence of continental margin. So in this what happened was, because the submarine canyons they actually resemble to the canyons that are formed on continent. Now because of this, the origin of continental canyons was only taken or was itself taken as the mode of origin of submarine canyons. Okay, so here what they said was that the continental canyons were formed by the erosional process of river, and subsequently these valleys that were formed, they drowned or they submerged inside the water. Okay, inside the sea. Okay, and these submerged valleys, they are now known as submarine canyons. Now these drowned valleys, they are known as submarine canyons, and they give various examples like Java Sea. We have drowned valley in Java Sea, Philippine Canyon, Monterey Canyon. They have been cited as typical example of submarine canyons formed due to subaerial erosion because of their longitudinal profile show upward connectivity like continental canyons. So they are having similar pattern like that of continental canyon, and that's why they are cited as typical example of subaerial erosion theory. Okay, next we have submarine density current theory. Now in submarine density current theory, the formation of submarine canyon is related to, or here the submarine density canyons, submarine canyons, their formation is related to density current. Okay, so we have density currents that are originated due to difference in density caused by temperature and salinity variation. Now because oceans, they have difference in salinity and temperature, and because of we have water moving from high salinity area to low salinity area, because of which the currents will be originated. Okay, and these currents, they will what they will be known as density currents, and such density currents, they will erode the continental shelves and form trenches within the continental shelves. Okay, and the stagnant water which is alongside, it will allow the formation of, oh sorry, not the formation of, it will allow sedimentation, and because of sedimentation we will have dike formation or levees formation. So levees will be formed and trenches will be formed, and levees will be formed at their border because of stagnant water sedimentation due to stagnant water. Okay, because we have stagnant water, so sedimentation will occur and the trenches will be formed by the current. Okay, now these density currents, they are formed mainly in front of river mouth. Why? Because see, the river will actually change the temperature and salinity of the area, because of which these current will be formed, and they will be originated they are basically originated due to this difference only. So these deep sea current are formed near mouth of river. Okay. But it is also pointed that density currents, they are confined to enclosed seas, reservoir, and lake only, and these are seldom originated over the shallow continental shells, and thus the density currents may not take a causative fact may not be taken as a causative factor for the formation of submarine canyons. Okay, because they are just formed near the reservoirs, lakes, and enclosed sea, but not in the ocean or vast ocean. Because of this reason, they are actually not taken as major causative factor for the formation of submarine canyons. Lastly, we have turbidity current theory. Turbidity current theory, here we have turbidity currents having fine materials in suspension, which are held responsible for held responsible by the several exponents for the origin of submarine canyons in one way or the other. Okay, so water is having various fine materials suspended. Okay, and these fine materials, they will actually by frictional force, they will erode the area. Okay. Okay, and this will cause the formation of submarine canyons. Now what exactly happens is, strong onshore wind piles up the water near the seashore, with the result under which results in undercurrent water. So because of wind, undercurrents are generated, and they flow towards the sea, and these undercurrents, they bring fine material in suspension. Okay, so these undercurrents, they are actually bringing fine materials which are suspended, freely suspended in them, and this will form turbidity current. And this turbidity currents is having higher density because of suspended sediments. Okay, which are forced to flow with seaward with seawater towards the sea under the surface water. So this is the surface water, and these currents are flowing under the sea and away from the continent towards the sea. Okay, towards the deep sea. And these materials, they are having high density because of suspended particles. Okay, so these turbidity current, they will erode the continental shelves and form submarine valleys and canyons. Okay, now initially these turbidity currents will be formed due to wind, but then what will happen, because they will be having high density. So here we will be having high density because of turbidity current, and here we will be having low density. So water or waves always moves from high density area to low density area. So this will increase the speed of turbidity current, and they will erode the continental shelves more, with more vigor and force. Okay, so this is how turbidity currents are formed according to several exponents. Now many critics, they have doubted the efficiency of turbidity current to form submarine canyons, because according to them the velocity of these currents is not such that they can powerfully erode the hard rock of continental shelves to form canyon. Okay, so this is critic of the turbidity current theory. Now for this criticism, Butcher, which is one of the exponents, he had actually an opinion. He said that the currents that are generated through earthquake and volcanic eruptions, they are more rapid and powerful, Hence, they are more capable of eroding continental shelves and canyons. Okay. Now, Quinen, he put forward that different localities have varying lithologies and structure, and there, so according to different lithological characteristics, we can actually explain the formation of these structure separately. Okay, so somewhere we can say that they are formed by drowning of subaerial valleys, while some are formed due to erosion, some are formed due to current, etc., etc. So this was whole about the formation and bottom relief features of oceanic floors. So that was all for today, guys. I hope you enjoyed today's lecture. Let's meet in our next class. Till then, take care and have a nice day.